Hello, Jean Dobre. My name's Alan Bao. I've been a SAS app developer for a number of years. And in this session, we're going to do a bit of a deep dive into automated deployments using the SAS.js CLI. So why build apps on SAS? Firstly, it's completely self-contained. Everything you need is pre-configured, such as the SAS web server, an application server, load balancing, and of course, dozens of access engines connecting to all kinds of databases such as Snowflake, Redshift, and Google BigQuery. Beyond superfast in-memory CAS and machine learning via actions, there's also formidable integration with enterprise IT. SAS provides LDAP integration, single sign-on, data encryption, SSL, full audit tracing, you name it. Beyond the scalability of SAS itself, web apps are inherently scalable. They can be deployed to any device with a browser, where they'll run safely inside that browser sandbox. They're also very easy to undeploy compared to, say, a VBA, R, or Python-based desktop app. The typical architecture then for a web app on SAS looks a bit like this. You have a client, could be an iPad or a laptop or a desktop, will connect to a web server, could be the SAS web server, and that will contain the HTML, CSS, JavaScript, also maybe PNG images, any static content. And the benefit of putting it there is that it can be released in milliseconds. It's very responsive. And from the web server, the communication is made to the SAS app server, and that might be the SAS stored process server on SAS 9 or the compute server on VIA. And this is where any data logic would be applied and any user-specific content. And that app server may talk to a database using one of the aforementioned access engines. In terms of deployment strategies then onto this kind of topology, certainly the fastest way you can get your app into SAS is just write it there directly, make changes directly on the production server. As soon as things get more complex though, and especially once you start adding more users and basing business critical reporting on the platform, this approach breaks down very quickly. You need to know what is changing in the environment so you can troubleshoot and roll back should incidents occur. A centralized model might involve a spreadsheet and nominated individuals doing the promote. This does introduce a bottleneck and a reliance on key individuals and doesn't necessarily make things any more transparent. It tends to improve stability at the expense of speed. Automated deployment is the only real strategy, especially in VIA where it's so easy to do. A change might be reviewed as part of a pull request and auto-deployed following a merge to a nominated Git branch, providing full transparency and the ability to run automated tests with every commit. Benefits then include a more stable environment, especially when deploying frequently, as smaller changes tend to be much easier to troubleshoot and to roll back. Regular deployments also make for faster feature delivery, which not only delights business stakeholders, but development teams too. They get to spend more time building cool stuff and less time attending release management meetings and filling out paperwork. Traditional tools for managing releases include Jenkins and Microsoft Release Manager. Major source control vendors such as GitLab, Bitbucket, and GitHub offer deployment pipelines or actions in GitHub, which has the benefit of keeping everything in one repository. Whichever tool you use, though, in order to actually connect to SAS, there are really three major options. Firstly, you can do it yourself using the REST APIs, which is the most flexible. It can also take a bit of time. If you like Python, you can base yourself off the PyVia tools in the SAS software GitHub repository. Because we're web developers, we actually built a Node.js based CLI for this called SAS.js. To demonstrate the kind of apps you can build with SAS.js, here's a Sonic game. This is really a simple iframe streamed through a SAS9 stored process. You can see that right there in the URL. The interesting thing is that you can deploy this app with just 2 lines of SAS code, as you'll see if you go to the GitHub link there. This rock roller game is deployed on Via, which you can see there being streamed from the files service. You can create it yourself using the SAS.js CLI as described in the GitHub repo in the link in the slide, bit.ly/sasrockroller. The Via token generator is a bit more practical. In order to consume the Via REST APIs outside of the SAS environment, you need to register a client's ID and a secret. This is used by client applications such as the CLI to obtain an access token, and that allows the app to make requests on behalf of the user. The client ID can be spawned with different properties, and those properties determine the level of access that will be granted to your application. Data Controller is a SAS app that provides a zero-code way to load data safely into SAS. It has 40 backend services in SAS, a database, control database, and is completely built and deployed using SAS.js. This video demo shows how we use JavaScript to import an Excel workbook where the relevant data is found and extracted and then sent to SAS for approval along with a copy of the original workbook. Here's one more video showing SAS9 data lineage from metadata extracted at column level, including business logic, and displayed using a JavaScript library that lets you export the lineage in PNG, SVG, and CSV format. Next up, build a Via app in 1 minute. So pretty much like it says on the tin, I'm going to read through this video. So we have a timer. I'm going to hit play and we're off. So the first thing is we go to the adapter GitHub repository and copy the code from the README and paste it into SAS Via. We change the app lock to the location we want the services to be created. And then we go back to, we kick that off, and then we go back to the GitHub repo and copy that HTML. We log on to the SAS server and change into the web directory, which is in var www.html. And in a folder called demo, we create an index.html file, paste in that HTML, update the config to the location we did before, and then the server type here is SAS Via. Save that file and then open it in a browser, hit refresh. We've got SAS logon. We log in with our credentials, choose a value, and now we make a web request to SAS Via. And that returns some data. It took 1 minute, 1 second. You probably noticed that that request took more than a couple of seconds. And the reason is that the Via web app that's running this request is handling the session management, it's waiting for the log, it's doing a bunch of things. So we added some extra configuration into SAS.js, which you can activate by setting use compute API flag to true, and then specifying the name of a compute context in which to run the services. With this setup, the adapter, instead of the JAS web app, will handle the session management and the log management, and the result, once you log in, and you can see the first time it still takes a few seconds as it does a folder map to get the URIs. But then the second and subsequent requests are very fast. They're under 1 second. So you can see here that using the adapter, using the SAS.js framework, does result in some very responsive via web applications. So I've talked about the SAS.js framework. What is it? It's made up of a number of parts. Each part can be used individually, but when they are used together, they provide a serious accelerator for SAS app development and deployment. The key components are a macro core library written in SAS, a bunch of macros, the adapter, which provides the connectivity to SAS, and that's written in TypeScript, and the command line interface, CLI, written in JavaScript, and this actually uses the adapter under the hood. And this first part to each bullet point at SAS.js/core adapter CLI, this is the location on Node Package Manager where each of these components are stored. The macro core library then contains over 100 utility macros to accelerate app development at the back end, whether that's standalone base SAS, SAS9 on metadata, or VIA. It can be installed locally in a Git project using npm and version locked, or it could be included directly from the Git repo in a SAS session using a %include, or of course it can be deployed in a traditional way using SAS autos. The adapter handles the SAS logon authentication and all of the back and forth between the front-end app and the back-end SAS server. It can be installed locally in an npm project with npm install at SAS.js adapter, or it can be installed in any web app directly using a traditional script tag. And the CLI then provides an opinionated project setup and a set of easy-to-use commands for handling common deployment tasks. It needs to be installed globally in order to be available in your preferred shell window. It's also worth noting that whilst you can use both the SAS macro library and the adapter without installing Node.js, that's not the case here. Just like SAS needs a SAS session and Python needs a Python runtime, the SAS.js CLI needs a Node.js instance against which to execute. It is possible to install Node.js in a locked down, no admin rights Windows machine, portable version, and I've provided an instructional link right there. Once you have Node.js, then the command to install the CLI is just npm install -- global at SAS.js/CLI. To use the CLI then, the first thing we need to do is add a target. A target is a configuration object that describes the SAS instance we are connecting to. Running the SAS.js add command provides a series of command line prompts, which you can see in the screenshot. The first prompt is whether the scope should be local or global. A local scope makes sense when working in a Git project. A global scope gets saved to the home directory of the user, and that allows the SAS.js commands to be used anywhere you like. Whenever calling the CLI for a particular target, the local environment is scanned first and then the global. The next prompt is server type, and that can be SAS9 or VIA, and the choice you make determines the questions and the defaults provided after. Target name is an alias that you give for the configuration you are making. App location, apploc, is the default root location used when deploying artifacts to SAS. If you provide a SAS folder location to any of the SAS.js commands without a leading /, they're assumed to be relative to the apploc of the target. If you do provide a leading /, the apploc is ignored and the path is assumed to be from root, the real root. Target server URL is the server on which SAS is deployed, and that URL should include the protocol, the HTTPS part, and also the port if it's not on a standard port. For VIA, we also need to provide the client ID and the secret, which should be provided to you by an administrator, with the relevant attributes you have specified. In order to make requests using this client ID, the CLI needs to authenticate to get an authorization code. To do that part, just click on the link and copy paste the token there, or the access code, authorization code. The CLI can then obtain an access token, which will be stored either in the home directory or in the local.env file, depending on the scope. That file is .getIgnored by default within a project. In the SAS.js project, if you're using it in a different setup, make sure that access token is protected. It's like a password, essentially. Finally, and this part is off the screenshot, you can choose the default compute context in which to run any SAS code that you need to run. And on that topic is the SAS.js run command, which lets you run some SAS code. Just type SAS.js run and the path to the SAS program you'd like to run. The log is then returned, and that is written to the current directory. On that second line there, you can see I didn't submit what the target was, but it doesn't matter because the CLI will scan my available targets and just pick the first one. The SAS.js folder command manages folders, obviously. Currently, we have the create, move, and delete actions. The first command in this list of three, you can see, is setting the target. As mentioned, this is optional. For create, the first one, you can also set a force flag, and that will do a create and a replace, which is handy if you're rebuilding a folder each time. A compute context, provides the attributes under which a SAS session will start, such as the autoexec, any SAS options, whether it's a pooled server for reuse, the system credentials, etc. And this screenshot is taken from a video which is there in the documentation, shown at the end. On the first line of that screenshot, we're exporting an existing context to a JSON file. And that's convenient because it provides a structure we can use for creating a new one. And we did that here by modifying the old one and then running the create command. After creating a new context, we then edit the JSON file again, and this time we change the name again to rename this context we just created. And we run that, it's successful, and then finally we run the delete command, which deletes the context. All those commands require like JSON input, whereas the list, export, and delete actions are standalone. There's no input JSON. You might also notice that there's no need to handle any UUIDs anywhere in any of the SAS.js commands. Everything is done using human-friendly paths and names. So all of those commands so far are probably helpful for pretty much any SAS VIA project. The ones we'll discuss next are specifically relevant for apps and SAS solutions. What I've found troublesome about some of the apps I've worked with in the past is that they were all structured differently. For instance, where the macros are stored, how they're included into services, where the services go, how they are organized, where the DDL and the data lines go, etc., etc. SAS.js create command provides a template setup which you can modify, but those modifications are always provided via the SAS.js config JSON file. That way, every developer knows exactly where to go in order to see what is or is not included within a build. When you create a new project, you provide a name and an optional template. The SAS-only template is just SAS, whereas the minimal, React, and Angular templates are helpful for creating template front ends as well. All of those templates also integrate the SAS logon, and the React and the Angular templates also include the log handling and debug mode. Here we can see the project structure for SAS.js Create with SAS only, and there are a few things to note. The packaged JSON files provide details of the third-party dependencies, which are physically downloaded and stored in the Node Modules folder. This is standard for any npm web app. The SAS.js folder contains the SAS.js config file and folders for build scripts, database files, macros, and web services. Everything SAS related sits in here, which means that it fits very nicely within the root of pretty much any standard web project. It is worth noting again that this is configurable. SAS.js config works on relative paths, so you can store the SAS.js subdirectories elsewhere if you like. You just need to run the compile, build, and deploy commands, which we'll cover next, from either the SAS.js folder or its parent in order for the CLI to pick up the configuration, the local configuration. So after we've added some backend SAS services to our app project, we can then run SAS.js compile. This will create a temporary folder called SAS.js build, and it will create one file for each service to be deployed. Each file contains all the relevant precode, including relevant macros and initialization or termination code. At this point, you're probably wondering how the CLI knows which macros need to be included. For that, we take a look at the program headers. So the headers are primarily used to generate HTML documentation using Doxygen. It's also used within the core library, as you can see in the screenshot here, and it's also used within SAS for some of the risk products. It's a pretty cool tool. The source code, at least in the SAS program, looks like this. You provide brief and detailed descriptions. You can use Markdown within that for code formatting. Each parameter of the macro can be documented. And what the CLI does is scan the headers of each of the program files and finds the macros that are listed underneath that dependencies tag on line 25. The source code then is extracted from the directories as specified in the SAS.js config. So to summarize, the compile command creates one file per service, each of which contains all of the dependent macros. And that runs recursively, so you get the macros within the macros within the macros. And the big benefit of this approach, of having all the macros self-contained, is that there's no file system dependency. Each service is fully self-contained and can be tested in isolation. For apps, so maybe you're thinking, my service depends on freeform SAS code or Lua programs, and for that we've got you covered, but it's not going to be available for another week or two. And what that will do is compile your freeform SAS program or Lua code using a data step and provide you a file ref that you can then include anywhere in your service to read that code back in. There's still the problem of deployment though. An app can have many, many services. How do we get all of these services into SAS? First, we need a build pack, and that's what the SAS.js build command gives us. There's two possible outputs. The first is a SAS program that can run either in SAS 9 or VIA, and that creates all of the SAS folders and all of the web services. It also contains any build initialization logic, such as creating or modifying a database or setting up the environment, and any termination logic, such as exporting the app as an SPK in SAS 9 or running test scripts. The second possibility for a build pack is a JSON file, and this is used to create services directly using the via REST API. SAS.js deploy then will first deploy the folders and services using the REST APIs if the server type is SAS via and deploy service pack is true. After that, it executes everything within the target deploy scripts array of the SAS.js config file, and all of the programs in there, by default they'll run locally unless it's a SAS program, in which case it will run on the SAS server. And here is where you could also add logic for building and deploying your front end, such as npm install, npm run build, and rsync. On the right, you can see an example of the target SAS.js config and how you could set that up. So as you've seen, there are quite a few commands, and we're still in the process of documenting them all. If there are any more commands that you think would be helpful, that you'd like to see, just head over to the GitHub repo and raise an issue. If there's community support, we'd be very happy to build it in. On that point then, I would like to show the GitHub site. So to get to the SAS.js GitHub, github.com/SAS.js, and we've pinned the main repositories along the top. You can see there the adapter, the macro core library, and the CLI. And you don't have to read code to use all this. You can also go to the website, the documentation website. So it's SASjs.io, and then you can learn, there's a quick start. There's lots of information here about how to build a web app on SAS. There are also 3 subdomains. So there's core.sasjs.io, and this documents the macro core library, which is the Doxygen documentation. There is the adapter.sasjs.io, and this is the technical documentation for the TypeScript adapter. And then finally, there's the cli.sasjs.io, and this documents all of the command line actions. So that's it. My contact details and the GitHub link are right here. Do reach out if you'd like to know more. We'd be happy to put on a workshop or a training session for you and your team. Do widzenia.